So, as we normally do with functions, every time we introduce a new type of function, we want to talk about its domain, what its range is, any sort of pitfalls that can come up in the exploration of these. And when it comes to the domain of any function, right, of any function at all, we've always said in the past, ask yourself this question: what can't happen? Right? And really, what that comes down to is there's certain situations, certain operations that have specific rules, right? One of them is if you have a fraction that doesn't matter what's in the top, even zero, fine, negatives, fine, big numbers, small numbers, whatever, up here, no problem. But the denominator cannot be zero, right? We're not allowed to let that happen. The other scenario was if we had a radical and we're trying to graph in the real number system, whatever's underneath that radical, it can't be less than zero, right? So these are two things that can't happen, right? We're not going to see any of these radicals with our rational functions. So we're not even really worried about this so much right now, but we're definitely worried about this because we're dealing with fractions. So if we're asking ourselves for a domain, what can't happen? We have to make sure that our denominator doesn't equal zero, right? And again, the numerator at this point is immaterial. It doesn't matter. But if you're finding the domain of a rational function, take the denominator and set it not equal to zero, right? Set up this inequality and solve this like you would solve any other inequality, right? We can add 16 to both sides here. And then we can take the square root and we get x cannot equal positive or negative 4, right? When we take the square root of this and we take the square root of this, we have to include both the positive and negative values, okay? So these are the exclusions from our domain, okay? I want to take a brief aside here and then we'll come back to what this means, right? What we're going to have to get in the habit of in terms of finding these values of the denominator that don't equal zero, okay? What are we finding? We're finding the zeros of, and I'm going to say d of x, right? That denominator all by itself. So what we've been spending in this unit a lot of time talking about zeros, right? The fundamental theorem of algebra. So when you're trying to find the values that would make this equal to zero, those are the zeros of the denominator. So that's what we're doing. And how did we do that in the past? We found zeros by factoring, right? So I chose this denominator specifically because this is the difference of squares. So you would be able to factor this into conjugates, right, as an alternative method for finding those zeros. And then we would say, oh, okay, well, we have x equals 4 here. So x, we're saying cannot equal 4. And we're saying here, x cannot equal negative 4 because those are the zeros and we don't want it to be 0, right? Okay, so focus on this non-equation or this inequality, right? So these are the values that we have to exclude, okay? And we're going to do more factoring to find these zeros than we are solving, but the choice is yours, okay? Now, these numbers where x equals 4 and x equals negative 4, this is worth noting, okay? These will be, because these are exclusions from the domain, these will be vertical asymptotes. Okay, those vertical lines that we saw in the previous video, right? When we exclude a value from the domain, they're either going to be a vertical asymptote or a hole in the graph. And we'll discuss what a hole in the graph looks like later on, okay? For right now, I'm just focusing on you understanding that to find the domain of a function, we set the denominator not equal to 0, or you can set it equal to 0, that's fine, but then at the very end, when you're getting your solutions, you have to say, oh, those are the values I'm excluding, okay? So we're going to say here the domain is from negative infinity all the way up to negative 4, because that's the first exclusion, right? And then starting again at negative 4 and going to the next exclusion, which is 4, and then not including 4 and going towards positive infinity. Okay, so this would be our domain in interval notation. Okay, you may see set notation as well show up in Math Excel. So they're going to say something like this: all values of x such that x cannot equal negative 4 and positive 4. So this is kind of a new notation that they start to introduce in this unit. This is just another way of saying this, okay? So they're saying all values of x such that x cannot equal -4 and 4. So we put the exclusions on the other side of this vertical line, okay? This is referred to as set notation. We've talked about interval notation, like so, to demonstrate what the domain is, all right? But again, set the denominator not equal to 0 and solve, and find the zeros of the denominator, okay?